Today we're going to look at the first conic section, and that's a parabola. And you all know what a parabola looks like. However, we're going to look at it in a very different context. So our definition of a parabola is a set of all points in a plane that are equidistant from a fixed line and a fixed point who is not on the line. So we basically start with a fixed point, which we call the focus, and then we have a fixed line called the directrix. And we want to find the set of all points who are the same distance from this point in this line. So we would know that right halfway in between these two there would be a point. And this point that is halfway between the focus and the directrix would actually be called our vertex for our particular parabola. And then we want to find all other points that are the same distance away from the focus and the directrix. So this point I showed right here would be an example of a point who's also on the parabola, because notice that the distance from this point to the focus is the same, or at least approximately so in my little diagram, as it is from the point to the directrix. If I picked a point further out here, if I'm curving correctly for this parabola, this little distance and extending that line out, this little distance would end up being the same. And so the set of all points who are equidistant from a fixed point and a fixed line is a parabola. Now, there are some different forms in which the parabola can take place, and I'm going to flip to this little diagram. I already did a few things in advance. And we're going to start out with the easiest form of a parabola. And you've studied parabolas before. You've had the vertex be in different spots. And we're going to start out looking at the parabola in the context of it being centered at the origin, with the vertex at the origin. And so here are our four general forms for having a parabola who is centered at the origin, where it will open up, down, to the right, and to the left. Now we can also have them be open on different angles like this. However, we'd have to do some trig and it would be much more complicated. So our parabolas that we're going to study are going to open up, down, left, or right. And we have to look at what characteristics take place for each of them. All right, so we're going to start with this form. So here is my parabola. It's going to be in the form of y equals ax squared, and we can see that it will go through the origin. Plug in 0 and you get 0, regardless of what this a coefficient is. We're going to deal with the first context as the a coefficient being positive, and we know that the basic parabola, if this coefficient is positive, will open upward. But now we're going to look at it in a little bit different context. Every parabola actually has a focus and a directrix. They are not part of the parabola, but they help make the parabola. So if I gave you this point as the focus, and we'll learn how do you know where to put the focal point and where to put the directrix in a little bit, but this form of a parabola would have a focus that would be above the vertex and the directrix would be low. We usually give the coordinate of the focus, the distance from the vertex we call C in this case. And so my vertex is at 0, 0. The focus will be located C units higher than my origin, and the directrix will actually be C units lower. And it will curve up like this. And if I curve this correctly, it will end up being, if I pick any point right here, that if I measure this distance and this distance, I will have it be the same. And notice if I come up here, if I curved properly, this distance and this distance will be the same. And we can actually use the distance formula that you used in geometry to find out, is this distance and this distance the same. So that's what the parabola will look like in the location of the focal point or the focus and the directrix, which is the equation of a line. In our case here, this equation of this line, because this y-coordinate down here would be at 0, negative c. The equation of the line for the directrix would actually be at y equals negative c. Now we can also have our parabolas open downward. We know that if our coefficient A is a negative value, that the parabola will open downward. So a parabola who opens downward, who is centered at 0, 0, will have a focal point who is below the origin, and a directrix, which is a line, who is above the origin. And again, the parabola will curve downward around the focal point. And if I curve this correctly, once again, I'll have it set up that if I pick any point on this parabola, I should have it have that distance and that distance be the same. So the set of all points who are in a plane who are equidistant from a fixed point and a fixed line is the definition of our parabola. Now, this point would end up being the point 0, negative c. This point would be the point 0, c. And the equation of that directrix would actually be y equals c. These, although you've never looked at a focus and a directrix before, you've seen the equations of parabolas who open up and downward. You've never worked with them who work open left and right. So here's an example. Looks kind of strange, but if I have x equaling ay squared, that's actually going to be a parabola who will open to the right if a is positive and to the left if a is negative. So I'll sketch a picture of what this should look like. Again, the parabola would open up around and curl around the focal point. If I choose a point who's supposed to be on this parabola, if I measure that distance, if I measure that distance, it should be the same because that's the definition of a parabola in the context of having a focus and a directrix. Now this point, because it's on this x-axis, would have a coordinate of c0. This point where it crosses the x-axis would be at negative c0. However, the equation of this line, which is the directrix, would be x equals negative c. And our last case that we'll look at is the idea of what happens if we have x equaling ay squared, but the a value is negative. It will curl around the focal point, and it will have a characteristic that this focus will be at the point negative c0. This point where it crosses this x-axis is at c0. However, the equation of that line would be x equals positive c. And those are the four forms that we will deal with. Now, we will also shift them left, right, up, down. But if you have your variable x squared, x being squared, and y is not, you will either have a parabola which opens up or down. If we have the y to the second power and the x to the first power, your parabola will either open right or left. Okay, and think to the left is negative, down is negative. Up and to the right are both positive measures. Now, what's the relationship between this little a and this c? How do you know? I mean, I keep talking about this little c, but I never even talked about how do you even find it from this equation. And that's what we need to look at on the next page. And so we're going to look actually right down at this part. And the relationship between the a and the c is the following. There's an inverse proportion here. The absolute value of a is always equal to 1 over 4c, and that is a relationship you're going to want to know. C is going to end up being, again, the distance between the focus and the vertex. And it's also the distance between the focus, the vertex and the directrix. If I quick flip back over again, sorry to flip, but remember if I look at just this one picture, this is the distance of C, this is a distance of C, this is a distance of C, this is a distance of C, etc. And we will have the characteristic that if we know what A is, we can always figure out what c is, because that relationship will hold true for every single parabola. Okay? So if we know the distance here, we can find little a, and if we know little a, we can find little c. Now, we're going to go back up, and I have the distance formula. We're going to put the distance formula down here, and remember the relationship from geometry, and we'll probably talk about it a little bit more in class about how to remember. This is really no more than Pythagorean theorem. But if I have a point, and I call it x sub 1, y sub 1, actually I'll use a marker here so it will show up a little bit better. And if I have another point, x sub 2, y sub 2, and we're trying to find out how far these 2 points are apart. It really is a little Pythagorean theorem. The distance is equal to the square root of the difference in the x's squared, because that difference is actually how far these two are apart on that horizontal line. And then we need to find that as well, which is the difference in the y's squared. And so this is really leg squared plus leg squared, and then square rooted gives us that distance. So, and you will be using that on an activity later on. All right, so we're going to find the equation of this parabola, basically using this idea. So let's go and read the information. So it says, write an equation for the graph that is the set of all points in a plane that are equidistant from a point 0, 1. So I got to find that 0, 1. 0, 1 is a point right there. So there's my focus. And the line y equals negative 1. So here's y equals negative 1. And that focus again is at the point 0, 1. Now, just looking at that, I can see where the vertex is right away. That vertex is halfway between these two. It is right there, good to go. The vertex is going to be at the origin. Now, I can see also that my parabola is going to swirl upward because it always curls around that focal point. So it's going to curl up like this and up like this. Now, it should be set up, and I can see just by eyeballing this that I didn't curl it up as quickly as it actually should, because if I take a point on the parabola, this distance and this distance should always be the same. If I pick another point here, and see how this looks like this is a little bit longer than this, so I probably should have curled that up a little bit higher based on what we have there. But we have enough information to go through and figure out what the equation of the parabola is. First of all, because it opens upward, I know it's going to be in the form of y equals ax squared. If it opens up or down, I know it's going to be in this form. If it opens left or right, this will be x and this will be y squared. Now, I also know that a is positive because it curls upward. And remember the relationship that we talked about just here, that I'm going to be able to determine what that a value is by looking at this relationship. And the distance from the focus to the vertex is my little c. My distance from the vertex to the directrix is little c. So I can see c as 1. Therefore, I can see that the absolute value of a is 1/4. Now I know a is positive, so I can write my equation. Y equals 1/4 x squared. That is that red parabola. Now you could turn the video off and just try this one on your own. I'll continue on. So you could turn it off, see if you have understanding, and then come back and double check. All right, so on number 2, we have writing the equation of a parabola, and we have an equation that has the vertex at the origin. So I know my vertex is here. I'll do that in red. So I know I have my vertex there. And I know I have a focus at the point 7, 0. All right, let's put that focus down. 7, 0 is going to be here on the x-axis. 1, 2, 3, 4, 5, 6, 7. So there's 7, 0. I know a little bit about this right now. That distance is called c. c is 7. I also know if I were going to sketch this parabola that if I go 7 units this way, 1, 2, 3, 4, 5, 6, 7, right here is where that directrix is going to be. The equation of that would be at x equals negative 7. And then I can see that my parabola is always going to curl around this focal point, so it's going to curl this way. And it has a specific curvature so that if I really pick a point here, I can see I actually curved it too tightly because this distance and that distance are supposed to be the same. So I can see that when I just eyeballed that, I made that too tight. It should be flatter, not bowling out as quickly as I had shown. But that's okay. We can find our equation. Now, because it opens to the right, I now know that my equation is in the form x equals a y squared. I also know if it opens to the right or up, a is positive, so I know and a has to be a positive number. So now I'm ready to find my equation. The absolute value of a has to equal 1 over 4c. I also know that my distance from my vertex to my focus is 7. So I know the absolute value of a is equal to 1/28. But I actually know it's positive because it opens to the right, so I can write my equation. X equals 1/28 y squared. And there's my equation. So writing the equation, if it's centered at the vertex of 0, 0, is pretty easy to do. We just have to remember that the distance from the vertex to the focus and the vertex to the directrix, that distance, is each of these is called c. And remember, the directrix is the equation of a line, and you need to be able to find the equation of a line. Now, the last question is going to be kind of a carryover of our reviewing how to write vertex form. And this one's going to be kind of a little bit backwards of the other. I'm starting out with the equation now, and I've got some x, whoops, can't see. I've got some x and y terms here other than just good old a y and a square, so a y and an x squared. So I can see that there's going to be some type of a translation here. So we need to review again how we put this in vertex form. So we'll start out, I've got my equation here. I can see that I can put it in a form of, with this x squared, y equals a times x minus h quantity squared plus k. So that's our vertex form, and we can see that this is going to be shifted some, and that's okay. We've worked with this in Algebra 2, and we worked with it yesterday. So I need to identify the vertex, the focus, and the directrix. Well, we had never worked with a focus and a directrix previous to now, so that's going to be the new part. But we need to get this equation into that form. So I'm going to keep my x's on one side, and I'm going to move my other numbers to the other side. So I'm going to subtract 8y from both sides, and I'll add 4 to both sides. Okay, now I'm ready to complete the square. And remember our review. We want to go to a different color here. We take this coefficient and take half of it squared will give us this number, but we have to make sure we add it to both sides. So half of that is 2, squared is 4. So I really do want to add 4 to both sides. And now this is a perfect square. We just manufactured a perfect square, x plus 2 quantity squared. Add these together. I have negative 8y plus 8. Now I'm almost done putting it in that form, and there are a couple things I can do. I'm going to subtract 8 from both sides. Almost there. Whoops. Subtract 8 from both sides. That's not looking too good, is it? There we go. Minus 8. That's a subtraction sign. Got marker. Not much I can do about that. Okay, and my last thing, I need to divide everything by negative 8. Well, this is divided by negative 8. This is divided by negative 8. This is divided by negative 8. Now I'm going to put the y in front. So I have y is equal to, and instead of writing that as a numerator and a denominator, I'm going to put it as a single fraction, negative 1/8. Negative 1/8 times x plus 2 quantity squared. And then I have this negative 8, and negative 8 is going to become positive 1. So So there's my vertex form. So now I had to find what information. I had to find, first of all, what the vertex was. So I know what the vertex is. The vertex is at the coordinate -2, 1. Okay, now I'm going to sketch that point up in my graph because that will kind of help me figure out what my where my focus is and where my directrix is. So I'm at -2, 1. There's my vertex. Now if we think about it, this parabola is going to open with this negative coefficient here. This parabola is going to open downward. So if I just kind of sketch in an idea of that parabola opening downward here and think, yeah, it's going down like this, which means the focal point is going to be down here someplace. And there's going to be a directrix up here. But I got to figure out where they are because that's the next step, is to find where do I have a focus and where do I have a directrix. So remember this relationship. This relationship holds true even if you translate your parabola. And so I know that the absolute value, A, is -1/8, and that has to equal 1 over 4c, or 1/8 has to equal 1 over 4c. Now I'm not going to do fancy algebra here because I can see just by looking at this, c has to be 2. I don't need to multiply both sides to solve for c. I can see just by spot checking that if I plug 2 right there, I will make the left side and the right side equal to each other. So c is 2. So now I'm ready to look at my picture. The best way to find the location of your focus and directrix is to look at your picture. So I look right up here. Here's my vertex. I know c is 2, which means I need to move down 2 units right to there to find my focus. So I'm going to have a focal point at the x-coordinate is the same as the vertex. It's at -2, but now my y-coordinate dropped down 2, so it's going to be at -1. And now I need to find my directrix. My directrix is a line, and it should be c units higher in this case. So I go up 1, 2, and it's a line. And I can see that this is a y equals line. And I move 2 units higher. This is a y-coordinate of 1, and I need to move up to 3. So there is my directrix. There is my focus. There is my vertex. And I have all the information I need. Okay, and now you're ready to practice.